Greetings, this is Unit 6, Module 3, Session 3. The name of this home connection is Bakery Bundles. It is a two-pager. Make sure you put your name and number at the top. Let's get going. Rachel owns a bakery and sells cookies by the dozen. She sold 16 dozen cookies on Monday. How many cookies did Rachel sell? You should really show your work with this one. So, 16 dozen cookies. Well, let's remind ourselves that 1 dozen cookies. Helpful information to have, okay? 16 dozen cookies. What can I do with this? So if 1 dozen is 12 cookies, okay, so this is what we know. 1 dozen is 12 cookies, and she has 16 dozen. Sounds like we need to multiply. So we're going to take this 12 times 16. Now, that might sound like a pretty complicated problem to work out, and you might be tempted to stack and multiply, and you can get the correct answer doing that. But what if we just added one step? What if I cut this number in half and I double this number? If I cut 12 in half, I get 6. And if I double 16, I get 32. Is that correct? Now, if you decide to stack and multiply 32 times 6, I think you're going to find that that math problem becomes a lot easier. And I'm going to let you solve that, okay? Let's move on to number 2. By the way, pause this video if you are not ready for question number 2. For each dozen cookies, Rachel uses 1.5 cups of milk. How many cups of milk did she use for 16 dozen cookies? So once again, we're going to have this multiplication problem. Why? 1.5 cups of milk for 1 dozen. But we have 16 dozen, so we need to count this 1.5 16 times. Okay? So if you say 1.5 times 16, what is that answer going to be? And I would like you to think about it this way. What if I asked you, what if I took 1 times 16? What would my answer get? Would you say it's 16? Let's write that down. I'll give that a color. I'm going to take this 1, I'm going to take it times 16. I get 16. What if I then take the half that's here and I multiply it times 16? What is half of 16? Because that's how you multiply fractions. 1/2 times 16 is the same as saying, what is 1/2 of 16? Well, I know that half of 16 is 8. The only thing I need to do now is add those two numbers together, and I have my answer. 16 plus 8, hopefully, is 24. And don't forget your units, cups of milk. I didn't really want to do all of that one for you, but I wanted to show you how you can break that problem up into much friendlier numbers, okay? A customer ordered 28 cupcakes. What are all the different rectangular arrangements Rachel could use to package the cupcakes? And I'm just going to go ahead and just say that I really think that we should just make a factor rainbow here, okay? Where we put 1 and 28 on the outside, because 1 times 28 is 28, and then we find our other numbers. And maybe this will make sense when we're done, okay? But I know that 1 times 28 is 28. What about 2? 2 times what? Well, 2 times 14. 2 times 14 is also 28. 3 is not a factor of 28, but 4 might be. What do you think? 4 times, hopefully, 7. Okay. 5 is not a factor of 28. What about 6? No, 6 is not a factor of 28. So those are the factors of 28, the factor pairs. Okay, because 1 times 28 is 28. 2 times 14 is 28. 4 times 7 is 28. Groovy? Now, how does that relate to the rectangular arrangements of the cupcakes? when we're looking at this, sorry, small interruption. If I think of the red numbers, 1 and 28, that would mean I would make a box that's 1 wide and pretend this goes on forever, okay? And I would just do 1 cookie at a time until I get to 28, okay? So because 1 times 28 is 28. If I look at my blue numbers, that would be just a little bit wider box where I have 2 cookies side by side, and then I go do 14 of those until I get to 28, okay? Because 2, right, see my cursor here, 2 times 14 is 28. So I'm going to go 2 wide, and I'm going to go 14 long, okay? And then if I look at I got to find my green color here. If I look at the green, I'm going to draw this up here. I'd have an even wider box where I'm 4 cookies deep, and I keep doing 4 cookies until I get to 28. And I would do that 7 times, right? Because 4 times 7 is 28. So those are the different ways that we could arrange the package and still get 28 cupcakes in a box, okay? Rachel's assistant says that 3/5 cup of oil is more than 2/3 cup of oil. So let's write that down just to make sure that we understand what is being said. 3/5 is more, alligator eats the bigger number, than 2/3 cup of oil. Is he correct? Well, the only issue is how similar these numbers are, but we can actually, without using logic, just do the numbers, can't we? Because I can say, what do 5 and 3 have in common? Like if I count by threes, 3, 6, 9, 12, 15, 18, 21, 24, or if I count by fives, 5, 10, 15, 20, 25, 30, 35, 40, what's the first common number that we have? And it does have a fancy word, but we don't need to know, at least today. But if I count by fives, 10, 15, 20, 25, 30, so on and so forth, right? What's the first number that I get to if I count by threes? 3, 6, 9, 12, 15. Ooh. Looks like 15 is a number that's common for both 5 and 3 if you're counting by multiples, okay? So we have to ask ourselves, how can I make that possible? How can I make that happen? Well, I know that if I take 3 times 5, I get 15, okay? Which means that I would also have to take this times 5, because you can't do 1 multiplication to the denominator and not do it to the numerator. And then on the other side of the equation over here, it's the same idea, other than to make 15, I can't do 5, I have to take 5 times 3. And whatever I do to the bottom number, I have to do to the top number. And I'm going to move this sheet over so I have room to draw, okay? What does that mean? That means at the end of the day, after I spell all of these out, let's see, I do all my math problems here. Down over here, 3 times 5 is 15. That's the number we were looking for. On top, I'd have 2 times 5. That's 10. So 2/3 is the same as 10/15. On the other side of the equation, over here, 5 times 3 is 15. That's great because now our bottom's numbers match. And then 3 times 3 is 9. So when I compare these, let me maybe do like an arrow. Maybe this one might be easier to see. If I compare 9/15 to 10/15, I now know which number is greater because I can compare them. Bigger or the same denominator, but the numerators don't match. Which number is actually bigger? The 10. 10/15 is bigger than 9/15, so this is incorrect. We should have written it, we should have written the other way. So I would disagree for all the reasons that we just said, okay? If you need to pause this video, please do. Otherwise, let's go to the next page. All right, on our next question, it says, Rachel uses 4/5 cup of cocoa for her brownies. Write 2 fractions that are equivalent to 4/5. I love this question because comes right after the one that we just did. We're starting with 4/5. You can change any fraction by multiplying. You just have to make sure that whatever you do to the bottom, you do to the top. So let's say that I wanted to double the numbers. What is doubling? Well, that would be the same as taking each number times 2, right? So if I were to take both numbers times 2, let me change my color back to my original one, then what would I have? 4 times 2 is 8. 5 times 2 is 10. There is an equivalent fraction. Those two numbers, how's my highlighter? I don't know if it'll look good today. But those two numbers are exactly the same in size. If I took a birthday cake and I cut it into 5 pieces and I took 4 of them, and then I had another birthday cake the same size and I cut it into 10 pieces, but I took 8 of them, I would have the exact same amount, just different sizes of pieces. Now, what can I do that is also the same? I could double it again, right? I could take each of those numbers times 2 one more time, and what would I end up with? 8 times 2 is 16. 10 times 2 is 20. Once again, if you were to cut up a third cake into 20 pieces, okay, and you kept 16 of them, everyone still has the same amount. Just the sizes of the pieces are different. Now, are there other ways that we could do this? Absolutely. I could triple, I could quadruple, I could quintuple. You could take each of the numbers times 10. You would have a fraction equivalent. A large order of 240 cookies was placed. Woof! How many cookies would go into each box if Rachel put them in different numbers of boxes listed below? You're going to show your work for each. I'm just going to put myself in Do Not Disturb here because I've got lots of messages coming in. And we can show our work, which is totally fine, okay? So we have 240 cookies. If I have 24 boxes, how am I going to put in each? Well, I could set up my problem by saying, what number times 24 would be 240, right? Because we said that we have 24 boxes. How many can I put in each box to get to 240? Well, use your zeros rule. I'm going to let you answer that one on your own, okay? How about the next one? Exact same questions. What number times 12 is going to give me my 240 cookies? Because I only have 12 boxes. So I'm going to have to put more in each box. In fact, I'm going to have to put probably double what I put in here because I have half as many boxes to use, right? If you wanted to do a little bit of, it's not really secret math, but if you wanted to do it this way, you could think to yourself, if I did 240 and divide it by 12, you would also get the answer. And you could say to yourself, how many 12s fit in 24? How many 12s fit in 0? And maybe do a pretty fast division problem. But if you want to, you could also do ratio table. You could do an area model. There's many different ways that you can do it. And I'm going to let you think about that. I'm going to do one of these with you, and it's going to be this last one. How many cookies can I put in 6 boxes and still have 240 cookies? Okay. If you reverse this, like we said before, you could turn this into long division and say 240 divided by 6 is what? And here's the nice part. If I said, how many 6s fit in 2? Well, you'd say none, right? And the nice part is that I know a lot of teachers put an X here, which is nice, just to remind you not to write anything there. But it also reminds you to multiply, because what do you do next? Then you say, how many 6s fit in 24? Well, 6 times 4 is 24, so I'm going to say 4. And now here's where the fun part of the X comes into place, because you can say 4 times, now it's a times, 4 times 6 is what? Hopefully you say 24. Oh, I would be helpful if I wrote the right thing. Now we subtract. 24 minus 24 is 0. Bring down the 0. How many 6s fit into 0? Well, hopefully none do. And now we're done. Technically, we could keep going. We could say 0 times 6 is 0. Okay. 0 minus 0 is 0. There's no remainder, though. Since anytime you zero out on an equation, anytime you zero out on an equation, when you use your last digit, you're done. There's no remainder. So 6 times what is 240? Well, 6 times 40. So you would put 40 cookies in every box. Okay? Hopefully that's helpful. Let's move on to the challenge. Oh, I love the challenge. All right, let's read through this. Let's do a lightsaber this time, though. Rachel had 1/4 gallon of milk left in her bakery. She needed to make 4 desserts for an order that afternoon. Use the table to help Rachel decide which desserts she can make 4 of with the milk she has left. Use equations, labeled sketches, or words to prove that your choice will work. So first, we probably need to figure out a couple things, and I'm going to write a little cheat sheet on the side. All right, so over here on the side, I have written that 1 gallon is 16 cups. 1 cup is 8 ounces. So we don't have a lot to work with. We're going to have to break these numbers down a little bit. Why? Because we only have 1/4 of a gallon. So I don't necessarily need to know how many cups are in 1 gallon. I need to know how many cups are in 1/4 of a gallon. So I could break this number up, and I could take this 1 and I could cut it into a half. Half a gallon would be half of the number up here. So that would be 8 cups. And we know if we cut that half in half, if I take 1/2 and I cut it in half, I get a 1/4, right? So that means 1/4 of a gallon would be half of my 8 cups, which is 4 cups. Okay, so I know that I'm working with 4 cups. Now, as I look at these, I might think to myself, ooh, I need to find some ones that don't have too many cups. Well, how many ounces do I have to work with here if I have 4 cups? Well, we know 1 cup is 8 ounces, so 4 cups has to be 4 times that, right? So 8 times 4, 32 ounces is how much I have to work with total. So how do you want to do this? Do you want to figure out how to convert all of the cups into ounces, ounces into cups? That is something really hard to think about because all of these are mixed up. Like if I see this 16 fluid ounces, that's 2 cups. That's a lot. I need to pick probably the recipes that have the least amount so that I don't run out of milk. I only have 1/4 of a gallon to work with. So what is the smallest amount that I have on here? Well, 1 cup is 8 ounces. Do I have any 1 cups or less? That's 2 cups. That is 1 cup. 12 fluid ounces, that's more than a cup. That's 2.5 cups. 14 fluid ounces, that's less than 2. That is 2. That's 1.5. So I'm going to have to probably start with probably the banana pie. And here's the tricky part. How many banana pie recipes could I make? Well, 8 fluid ounces. So if I even set up a mini ratio table, if I did like this, if I did 1 recipe is 8, 2 recipes would be 16, 3 recipes would be 24, and 4 recipes would be 32. I'm done. That's all I can do, which means that if I can only make 4 recipes, that is all that is available to me. So the only thing that I can do is 4 banana pies. Otherwise, the other ones are too much. Too much, too much, too much, too much, too much, too much. I'm going to go over the amount that I've been given. So the only way that I can make 4 desserts is if I make 4 of the smallest desserts, which is banana pie. Okay? And if you need any help with that, make sure you come ask a teacher because we love to answer questions. Check you guys later.